Welcome to the Math 8 Flipped Classroom. To begin, we need to set up our notebook to be able to do the flipped classroom. So I want you to take your notebook, your spiral notebook that you have, and I want you to use the following instructions. So I'd like you to take your notebook and with the cover closed, but then I want you to open the cover. And on that first page, the absolute first page of your notebook, I want you to write your first name and then your last name. And your actual first name and last name. Don't write first and last. That wouldn't make much sense. But write your actual first name and last name. Underneath that, I would like you to write Math 8. And then underneath that, I want you to put the period that you are in. Now, if you need more time before I move on, pause the video. If you're ready to move on, keep going. Now, turn to the next page. And each time you watch one of these videos, you will always do the exact same thing. It will start by titling the page. So at the top of the page, on the big bar on the page, I want you to put 1-1 rational numbers. Because that is today's topic. 1-1 rational numbers. Now again, if at any time you need to pause the video to write something down, please go ahead and pause the video. If not, let the video continue to run unless I tell you to actually pause it. Underneath this is where we're going to start putting our notes. And today's note starts with all about the number system. And we start with our smallest number system. The smallest number system are the original numbers, the numbers that even cavemen were able to use. And these numbers came naturally to the cavemen, so they called them, as they were, natural numbers. And the natural numbers were simply 1, 2, 3, 4, 5, and so on and so on. This is what we call a set of numbers. In this case, it's the set of natural numbers. Now, as you're looking at that set, you'll probably notice that there is a number missing. What number do you think is missing? 0. Now, funny thing is, actually, even though we look at the natural numbers this way, as 1, 2, 3, 4, 5, when people started doing math, and even in the cave, in the prehistoric days, and even in like the Roman days, they didn't use our numbers. Like the Romans, they didn't need a 0 because their number 10 was an X. So you don't need 0. But when we use our number system, we need that concept. But 0 was not natural. So 0 cannot be part of that set. So we actually put it outside of that set of numbers. But if it's outside, you see, mathematicians don't like that. They don't like having two sets of numbers. You can't have the natural numbers and 0. So they want to put them all together. So they take this number system and they merge it together into one new system. And they call this system the whole number system. Because it felt like all the numbers were being used, right? So that's the whole number system. Now, obviously, you know there's also another problem here. Because we know that if we count down 5, 4, 3, 2, 1, 0. Uh-oh, what's the next number? And no, it's not blast off. There is no such number as blast off. So there is another number there, and that number is the number -1. Then we go to -2. Oh, but if we're doing that, if we're having those numbers, can we call them whole numbers? No. And we can't have the whole numbers and the negative numbers. We have to combine them all together. So we merge them all together, and we get a new set of numbers. Anyone know what we call that new set of numbers? Not negative. They're called integers. Negative numbers are only -1, -2, -3, and so on. What do we call numbers like 1, 2, 3, 4, 5? Well, yes, they are natural, but they're also the positive numbers. Is 0 negative or positive?
Neither.
It's neither. 0 is neither. Now, we move on to our next set of numbers. See, now here's an interesting thing. See, one day there was a king. And the king was eating an apple. And he took this apple, his one apple, and he placed it on the table. And some jester came in, ran up to the king, took out a huge machete, and went right through the apple. And took part of the apple and ran away. Now the king was devastated. And someone said, "My king, how much apple do you have?" But the king couldn't answer, because there was no such number that represented how much of an apple he had. So you know what they did? They created a new number system. They created numbers like 1/2, half of an apple. Numbers like 0.7, 7/10. Numbers like 0.6 repeated. These were some new numbers that have never been used before. But we had to incorporate those numbers within all of the integers. So if we put all those numbers together, you know what we get? We get the set of rational numbers. We get the set of rational numbers. Now, is every number rational? No. Not every number is rational. There are numbers that are not rational. Can anybody give me an example of a number that's not rational?
0.
Nope, 0 is actually a whole number, which means it is rational because it's inside the rational box.
Trillion?
Trillions actually, believe it or not, it's a natural number because it's a positive number.
Infinity.
Infinity is actually a rational number. It has an unlimited number of zeros, but it is still a rational number.
1 1/2?
Actually, 1 1/2 is a rational number. A rational number, and we'll talk about this, but it's a number that can be written as a fraction. And 1 1/2 is a fraction. So maybe there's another number. And I know you know it. Yeah.
0.6?
0.6 is actually a rational number.
Wait, no,
pi. Pi is not a rational number because it's a decimal that never ends. Now that's not what pi is. Pi is 3.1415927, so on and so on and so on and so on and so on. Point 1, 2, 3, 4, dot, dot, dot is a decimal that never ends. It's like the song that never ends. Don't start. Okay. When we have numbers that never end, we call them irrational numbers. But the irrational numbers are kind of out there on their own. They don't fit in with the rational numbers. But do mathematicians like to have two sets of numbers? Can I have on one hand the rational numbers and on the other hand the irrational numbers? No. So they went ahead and they put those sets of numbers together. And you know what we call when we merge the irrational numbers with the rational numbers? We call them the real numbers. Any number that can be written is either rational or irrational is called a real number. Now, I know what you're thinking, because I can hear you laughing. You're going, real numbers? That means there's fake numbers too. There are.
What?
Actually, we don't call them fake. We call them imaginary numbers. We call them imaginary numbers. Now, I know you know what a square root is, right? So if I asked you what is the square root of 4, you would tell me 2. And the square root of 100 is? Not 50. Square root of 100 is? 10. Square root of 25 is? 5. But what's the square root of -1? Is there a number times itself which will give me -1? 1 times 1 is 1. -1 times -1 is 1. So there's no such thing. That's an imaginary number. Now, once again, I have the set of real numbers and I have the set of imaginary numbers. If we merge them all together, we get this giant set, which is called the complex. Oops. I spelled that wrong, so let's spell that right. The complex number system. This is the complex number system. For our purposes, for this class, we are actually only going to study up through the real numbers. Complex numbers, you'll learn that when you get to Algebra 2. For us, we're just going to focus on rational numbers. So let's start with a definition. Definition. A rational number is any number that can be written as a ratio of two integers. A rational number is any number that can be written as a ratio of two integers. For example, Oops, no, I don't want to do that. Let's try that again. 4/7. Is that a ratio of two integers?
Yes.
Yeah, 4 is an integer, 7 is an integer, and 4/7 is a ratio. So that's a ratio of two integers. What about 0.75? What about 0.75? Is that a ratio of two integers? It is. It's 3/4. I can convert 0.75 into 3/4, which is a ratio of two integers. What about this? Here's a rational number. 19%. That's a rational number. Can I write that as a ratio of two integers? How can I write that as a ratio of two integers? Very good. That is actually 19 hundredths. So 19% is a ratio of two integers. What about 3 1/5? Can that be written as a ratio of two integers? Yeah. No, it isn't already. That's actually a number and a ratio of two integers. But can I write the whole thing as it? Absolutely. What's 5 times 3? Plus 1? So I could rewrite this as 16/5. And now it is a ratio of two integers. Make sense? Okay. Take a look at this. So take a look at this. Write the fraction, that was terrible. Write the fraction as a decimal. Write the fraction as a decimal. Does anyone know how to do that? How do you write a fraction as a decimal? Well, let's take a look. If I gave you, for example, let's see. Let's do 5/8. How could I turn 5/8 into a decimal?
You divide 8 into 5.
I divide 8 into 5. I take the 5 and I divide it, that's the numerator, I divide it by 8. So let's do that. Does 8 go into 5? No? No, it doesn't. Add a decimal, add a 0, bring the decimal up. Does 8 go into 50?
Yes.
How many times? 6 times. Okay? So 6 times, that gives me 48. Subtract, I'm left with 2. Add a 0, bring it down. Does 8 go into 20?
Yes.
How many times? Twice. That is 16. 20 minus 16 is? 4. Add a 0, bring it down. 8 goes into 40? 5 times, which is another 40, which is 0. So 5/8 is actually 0.625, and I've just written my fraction as a decimal. I would like you to try this problem. Write the following fraction, or I should say, write the following rational number, -1 2/3, as a decimal. Pause the recording so you could work on this, and then start the recording up to see if you did it right. All right, let's see if you did it right. If you did this correctly, you would have first actually taken the mixed number and you would have made it into an improper fraction. Ignore the negative sign for a second. 3 times 1 is 1, plus 2 is 5 over 3, and put the negative sign back on top. Now actually we'll ignore the negative sign again when we do the division, because now we're going to take the numerator and we're going to divide it by the denominator. 5 divided by 3. See, 3 goes into 5 one time. Add a decimal, bring it up. Add a 0, bring it down. 3 goes into 20 6 times. That's 18. When I subtract, I get 2. Wasn't that going to do the same thing to me again?
Yes.
So doesn't that mean that's going to repeat?
Yep.
But I've got to have that negative sign, so it's going to be negative 1.6 repeated. And there is my rational number in decimal form. I'm going to leave you with one more problem. And the problem I'm going to leave you with is I would like you to write this rational number in decimal form. And the next class time, we are going to see if you got it correct. I want you to convert 4 and 13/25 into a decimal. Have a good night, and I'll see you next class.